So good morning, everyone, and welcome to our webinar that has been organized in the scope of our H2020 project, the Amsec project. And I would like to welcome my colleagues from CEA in France, Mathieu Gallissot and Radhouene Azzabi, for their participation today. Thank you so much, Mathieu and Radhouene. And they will be discussing the topic of the webinar, which is end-to-end security management in smart cities. So thank you so much to both of you and welcome.
Can you just confirm that you can hear me?
Yes, we can, Mathieu.
Okay, sorry, I had a slight problem. So, good morning, everybody. Today, I will introduce you the end-to-end security management that we have specified and implemented within Amsec. In order to do that, I will start by presenting you some challenges related to cybersecurity in smart cities. Then I will present the Amsec project and the underlying component that we have been implementing in order to secure IoT devices, cloud access, and application. We will talk about security management to be sure that device can work all together with cloud and citizens. And finally, we have prepared a small demonstration in order to you to visualize our developments. So let's start with a little bit of context. I chose to illustrate a story of a large-scale attack, and maybe you heard about this attack. It's about the DIN attack that happened in late 2016. This attack had a lot of noise in the news because during many hours, almost 10 hours, major websites mostly in US were unavailable, such as Airbnb, Amazon, GitHub, Netflix, and PayPal. And actually what happened is that some IoT devices that were not secured off was at the source of this attack. And mostly IP cameras, such as the one you have in smart cities. It all originated from a botnet called Msa. This botnet actually scans for devices on internet. It scans many IP addresses, and it tests if it can connect to any open port. And originally, it checked for console ports such as Telnet or SSH. Once it finds this port, it tried to log in using brute force. So actually, it was with a table, as you can see in the source code. This table used predefined login and username password. Actually, these are the default credentials that you can find on embedded devices, such as those IP cameras and so on. And what happened is that most of the time, installers doesn't change this default password. They keep it. And as you can log in onto this device, then you can load some code. And this is what happened. The Msa code loads itself into the device, and then it reports to a control and count server that the device has been hacked. And once it's done, then it does it recursively. So each device that has been hacked continues to act over the device. And this botnet spreads recursively by this manner, and it can also spread in private networks. So the devices that were targeted was mostly Linux-based devices running a kernel 2.6, which is quite old, but we can find it quite often in embedded devices. And devices such as IP cameras are connected with a lot of bandwidth. Since they have to transfer video streams, they need bandwidth. And this bandwidth can be used then to trigger distributed denial of services. And that's what happened. So this botnet was discovered in August 2016 by a group of white hat security tester, which is called malware must die. And 1 month later, it was discovered and published. There has been 3 major attacks. The first one was targeting a website from the security journalist Ryan Krebs, and it was triggered at 620 gigabytes per second, which is monstrous, enormous at this time. And so the website was unavailable as it couldn't handle that much traffic. And at the time, people were wondering what was happening, how this much bandwidth could be triggered. But that was the beginning, because a few weeks later, the same origin was used to attack the OVH data centers in France. And we estimated this attack to be at 1.1 terabyte per second, which was a total breakthrough record, and nobody understood how it could happen that much. And the forensics work that happened at the time show that it was triggered by IoT devices. But still, it took time, and 1 month later from the first attack, the DIN server occurred, the DIN attack. It was on the 21st October, so it was more than a month later from the first attack. So what can we get from this? What are the lessons? Well, the first one is that the IoT devices were not installed properly. That was the first vulnerability, because people keep using the default password. They were also vulnerable because the telnet port or any other console port was still accessible, while it should have been protected, even though by a firewall or using updates or with other means of protection. And at last, they were not updated. So even though the botnet was discovered and published, it still took almost 2 months from August to October to correct this problem. And this is because most of the time people forget about this. We install we take care anymore of them. So this is manage IoT device as well as we can manage computers. The botnet is, I took as example an attack on 2016, but as you can see on this graph, we still have a lot of botnets, and they are more and more targeting IoT devices, as the forensics we can do using honeypots or so on shows that the botnet are precompiled for many architecture from embedded devices such as ARM, MIPS, SH4 from Renesas, and so on. So the botnet are targeting IoT more than they are targeting regular computers. And attacks continues. We still see every month proof of attack targeting cities, targeting transportation network, targeting energy grids, and it doesn't stop. So, the vulnerabilities that are targeted by this bot are numerous. It can be for trigger distributed denial of service. It can be to steal data, to steal mostly private data, or any any bank account credential. Some of them are mining Bitcoins, while they are not used that much. We still see many kinds of attack occurring on many layers. It can be on the physical device itself, it can be on the connectivity on network layer, it can be on the data, or it can be an application manipulation. So it's what we call full stack attacks and still targeting IoT. The breach, so I spoke about the malware mostly, but there is also denial of service, brute forcing, man in the middle. There are physical attacks and attack on encryption. They are also evolving and try to seek as much damage as it can be in most time. And actually, attacking IoT is becoming a business more and more. So our drivers for enhancing security. First of all, there is more and more IoT in many domains. I talk about energy grid, transportation, cities. We see that the number of devices continues to increase. We also have new regulation and policies. So, for example, in Europe, we have the CyberSecurity Act, which will put labels on security from the device. So we can have three levels that will be certified using different schemes. So, for example, basic security, non-security, or really advanced security. But we also have regulation frameworks for privacy, such as the GDPR, which was also explained in a previous webinar. These new regulation policies goes to really improve the security level that we can have in cyber physical systems. Another driver is the high number of ransomware attacks. These attacks are really increasing, as shown earlier. And actually, it's a call for having more trust in our digitalized infrastructure. And we also have new technologies and advancements such as blockchain, artificial intelligence, machine learning, and so on, which really improve services that we can get from daily lives and for our businesses. And it's actually the IoT security is a growing market with a lot of opportunities. So smart city is one of the fastest growing segment for this IoT security, with more and more spendings. And we seek for a 4.4 billion opportunity for next year. So it's a really growing market. Okay, so this was for the context to introduce our motivations. And then actually we are addressing this motivation in the Amsec project. I will show in this part different components that we use in order to provide a framework for security in smart cities. And we call this multi-layered security technologies because we have different parts depending on the value chain and stakeholders. So we have IoT devices as a first layer, cloud as a second layer. Then we have blockchain and end-to-end security. Each of these layers, Amsec partner has brought some components, assets in order to improve the security specifically to one layer. So if we go in this architecture, it's you will find similar architecture quite often. So in smart city, you will have devices connected to gateways, which will provide data, feed data to a smart city platform. This platform, mostly located in the cloud, will manage data and access for smart city application that will go to vertical segments. And one of the novelty of Amsec is also to bring a marketplace based on blockchain, which provide the ability for any third party to, in a trusted manner, buy and use data from the smart city platform. So this kind of architecture is more and more challenged on trust, and this is why we need security. I will framework more in details, and I explain roughly, but not extensively, some components, because we also had previous webinars on this subject. So for this secure device, we have many approaches. One of them is to use and one of the approach we have is to use, for example, secure elements and standardized ones such as TPMs, which can be embedded on gateways or on the end devices to bring many functionalities that are standardized by the trusted computing group. So it can be encryption, it can be integrity monitoring, and so on. We also intrusion detection system that can help the devices and the infrastructure to understand if the device is under attack or not. And it can be fed with some specific signature that are provided by a monitoring and visualization tool that helps to keep the signature up to date. And it's also a tool for infrastructure administrators, at least to monitor the device and understand what's happening in real time. We have a functional block called Secure and Trusted Storage. Actually, it's based on Chrome blockchain framework with some predefined smart contracts that can provide a marketplace and a trusted trust and reputation model to be sure that people acting on the blockchain, doing transaction, are trustful. And one of the drawbacks of using blockchain sometimes is to handle private data. And this is why we also have an off-chain architecture with a fully encrypted database. It's called the Crypto Companion database, and it's enables us to still have the ability to manage private data without publishing them in a blockchain. So it's an interesting feature that really enables some trustful data computing. We have two frameworks for smart city data access. One of them is the open source Sensinet platform, and the other one is the Chaos Foxfire platform. This middleware enables us to manage data stream from the devices and also the connection and the API to end user application. Speaking of security, we also have a security analysis tool as well as a honeypot that help developers and designers to dimension their infrastructure. And we also have a really cool algorithm, which is the GAN anonymizer. It's actually remove any private data from live video streams. So for example, you can have a camera in a smart city, and it removes every private data, such as people or license plates and so on, in a live manner from the video stream. And all of these components actually need to be connected interfaces from a security point of view. So this is why we have this end-to-end security module that we will be demonstrating later. So as said a bit earlier, we have a series of webinars. If you want any details about this framework, technical framework, and the underlying components that are brought by Amsec partners, then you can go on our YouTube channel to check previous webinars. And we also release a cookbook with a set of technical information in order to use these components. We are demonstrating actually these components in different use cases that will be implemented in both Fujisawa in Japan and in Santander in Spain. So we also have a webinar on this use case, and it's really cool to see how we put in practice these different security layers. So just to keep in mind that we are going on the field with these technologies. Okay, so now I will talk about the security management in this infrastructure and what I call a step towards cyber resilience. We are using the NIST framework that you can see here on this slide to map our security technologies and be sure that we have a full addressable security. This framework actually is quite great because it gives every steps, every function you need to have a secure city. A first step is to identify. It's like you need to identify your risk by risk assessment, risk management. You have to identify who's taking care of your cybersecurity in your organization, and you have to identify the threats. Second step is to protect. Once you've identified your threats and your risk, then you take actions to protect. You can protect your device, you can protect your data, you can protect your management, and so on. Another step is to detect, to have the ability to monitor and to check if everything goes right as expected. And the two other steps are not addressed that much. They are quite new, so it's to respond and to recover. We have mapped the previous components that were explained into this framework, and the motivation for having end-to-end security is that we have many components to protect devices, to protect data, to protect privacy. We have components to identify threats. We can also detect threats. But how to respond? What can we do when we are under attack, when a vulnerability has been discovered? How to respond and how to recover as quickly as possible from this. And if we can remind the example that was introduced, it took 1 month to recover, and because we had 3 attacks. So if we can do it in an automated manner, then we also reduce the attack surface to cyber hacker. And this is how we came with this end-to-end management. So this end-to-end framework has 3 main functions, which are more classical in computing. So authorization, accounting, and authentication. And this is what you have mostly in IT. So your laptop you are quite using every day. These servers and so on usually use Active Directory or LDAP directory to authenticate people, to authorize people to access to certain resources given specific accounts. For IoT devices, we needed to extend that with a bit more things. So we added some anonymization capabilities, but more importantly, in our context of today, we added auditing function for secure device and attestation. And these 2 features help us to monitor the the actual device, if they are in a correct state or if they have been compromised. And it also helps us to attest in a cryptographic manner their level of security. So the underlying infrastructure from, for example, the cloud, blockchain application, citizen connecting to through application, they can know that the device which are behind their data, they are trustful. This framework is based on 3 modules. So we have Pke module, which can provide a public key infrastructure for issuing certificates to devices and to manage account to devices. So we can have customized security for each device, and actually it avoids to have, for example, one generic account with full administration right for each device. We have a directory module which helps us to have a public repository where everybody can check accounts. When I say everybody, it can be external program, third parties, administrator, users, and so on. And an identity module that help mostly citizens, for example, using interface such as O2 or OpenID, to use the infrastructure in an authenticated way. So the goal is to avoid any anonymous connection and be sure that we can have accountability on each user in the infrastructure. We try to keep an approach where it's open and standardized. So you have a list of APIs, for example, OCSP for dynamic certificate verification, SCSL for the web service securization, LDAP for the accounting, OpenID, and so on. So as infrastructure, mostly in smart city, are very heterogeneous, we needed to have that standardization, that level of standardization, and this aggregation between each module. So to avoid any gap into the infrastructure. Okay, so enough slide set. I will leave the floor to my colleague Radhouene, which will do a live demonstration of how it works. The floor is yours, Radhouene.
Okay, thank you, Mathieu. And I will start to explain the approach. So the Amsec approach to privacy is to automatic breach notification and inform user for each breach based on RGBD spec. So here, for example, we have a smart city IoT devices. These devices are audited on a regular basis. We have in the other side different users that connected to our platform with OTH2 or OpenID mechanism. If a device gets attacked, so the OT link will fail, and the Amsec security manager will put these devices in the quarantine group and then notify the security owner or the security user subscriber for this breach. So to achieve this goal, we have implemented an end-to-end IoT security framework, which is composed as follows. So here in the right side, we have the most component of our security end-to-end management. So we have using a tokenized component. We have a core component for security layer. So we use KeyCloak, we use FreePA, and we implement the Amsec manager. We have in the other side application component. We can use any application that we want. For the demo purpose, we have introduced a Grafana component for monitoring devices. All our systems are behind an Nginx routing layer, which is responsible to route and authentify all requests. And then we can find different services available, such as auditing, attesting, anonymization, authorization, etc. So for the demo's purpose, we have introduced a new user. We call this a demo Amsec, which will be used belong the demonstration. As a data provide, we will use a gateway Raspberry Pi with the TPM modules. And for the HMI interface, we will present free API interface, Amsec manager interface, the Keycloak interface, and the Grafana. So we have worked with two identity manager tools. So we use free API as Linux user and the client host management. Is a service provided centralized authentication, authorization, and account information. It can storing donc user, group, hosts, and other necessary to manage security. In the other hand, we have introduced a Keycloak, which is an open source identity and access management solution. It is an open source identity tools. It is recommended for modern application and services, and it can add authentication to application security without without minimum phase. So we can include authentication in any application needed. So to be clear, free API belongs to system operating system management, and Keycloak it belongs to application management. And in order to take advantage of the two benefits of this two component, we have configured the user federation. So free API share the same user database with Keycloak. Okay, so for the first flow of our demonstration, we will demonstrate how any user can connect to our infrastructure and can be authorized to log in or log out on any application. So the first flow that I will demonstrate is that the administrator connect to free API application and create a new user. Then he will save it in the Ldap database, and we will show that based on the user federation, the Keycloak will synchronize the user and they get all information in Keycloak. And then user can connect to application layer with the same credential that installed in FreePA. Also, Keycloak allow us to use social login. For example, we can connect with Google login or Facebook login, etc. So this is the first video of our demonstration. So here in the left side, I have a login, a Keycloak interface. And in the left and the right side, I have the free API login interface. So I will connect as administrator of Amsec tools. And in the other side, I will connect with the free API admin tools. So we can see, for example, here in the left and the right side, the list of users available in our infrastructure. For example, I have the admin account, Amsec Keycloak account, Amsec manager account, and I have created a sample user account. Then if we look to the Keycloak users, so we will find the same beside admin's login. So now I will add a new user in Keycloak. So I will call it demo Amsec. I keep a password. Okay, it's not too strong. So here in free API accounting tools, I have created a new user which called demo Amsec, and automatically I have a mail which is a demo Amsec at our domain, which is amsec.local. So then in the left side, in the Keycloak interface, we can find the same user with the same identity and with the same email address. So now I will update the address email of this user. So I put it my personal address mail. Then, if I refresh the page, I will obtain the same address email. So this is very interesting because now we will show you of AutoTH or OpenID authentication, which is, for example, in this our case, we have implement an Amsec interface manager. And in the other side, we have a Grafana interface. So the two applications are secured via a Keycloak authentication. So now I will connect to Amsec Manager with the new user created. So I have access, which is demo, etc. And the other side, we have in our store another application which is Grafana for monitoring purpose. So I can connect with the same login and password. So authentication is centralized via Keycloak authentication. Log out. And I will log out for this. Okay, so next we will demonstrate another aspect, which is host management, and we will define authorization and access control. So in our strategy, in the API,
tu fais pas rien sur ta photo.
API,
non, c'est vrai, apparemment ça a circulé à mon. Peut-être t'es militaire. On dirait les Chinois qui. Moi je rigole pas.
Antoine,
les Chinois qui font leurs photos.
Antoine, désolé, est-ce que tu peux couper ton micro? Merci.
Sorry. So on the other hand, we will work with the group with host management, and we have defined a different group and different host-based access control. So the admin or user will configure the gateways, and then they will enroll them in the API domain. The same thing with server, but here for the group of gateways, we have added a new paradigm, which is a physical security with TPM component. So TPM, which is a trusted platform module for Raspberry Pi, it contains a persistent memory with an endorsement key. It contains a versatile memory with different registers. We call this PCR, and we have an attestation key with which called AIK. So with TPM, we can do some cryptographic call process, and we can generate some security key. Also, we can do some remote system attestation. So as explained in the official website of TPM, can capture the host system state, and we can compute the integrity of our system and register it in TPM. To explain some keys, so we have a CA root key, which is stored by manufacturer in the TPM devices. And we have a TPM endorsement key, which is an encryption key generated in the TPM and stored in the TPM hardware. We have a TPM endorsement certificate, which is signed by the TPM manufacturer and stored in the TPM NVRAM. And we have the attestation key, which is a signing only key generated by the TPM. So these keys are involved in our TPM attestation protocol. So the attestation protocol is composed by 3 master steps and one optional step. So first of all, the client contacts the attestation server and request a nonce in order to prevent replay attack, and then list of PCR to sign it. Okay. Then the server sends the nonce. The nonce will be used in the TPM part after generation a TPM endorsement key, and we will generate an attestation key inside the TPM. Then we will use the DPM to sign the code, which is a list of PCR that we will attest it. In our case, for example, we have in our TPM module, we have 24 registers which contain some integrity computation of our firmware. So we can check and validate the integrity of our system with this integrity check and save it in the PCR. So then we compute the PCR code, and we added all this file in one bundle file. We call this a code PCR as a compressed file. Then the client sends this code file to the server, and the server, when he receives the code file, it runs a validation of SSL certificate to check that the TPM key is issued by a real manufacturer, and it's a real TPM devices, not vulnerable devices. And then he unpack the code file that received, and he tests the correctness of the code, which is signed with the nonce sent in the first step. So if the nonce is not checked, then it can be a replay attack by the client. So we can emulate a different type of attack inside the TPM, but today we will demonstrate this simplest attack, which is attest TPM devices with a non-good nonce. Then the optional step, which is a PCR verification. So after the registration and the enrollment, the TPM in our infrastructure, we will start a TPM remote attestation procedure, which is a loop every x minute, which done the same the same protocol, but he check every time the PCR if are good or not, and the comparison with the register that save it in the first step. So in order to add all this and to integrate all this in our infrastructure, we have done some extension. So we have modified the Ldap schema to support the new type of a Raspberry Pi with TPM. So we added 24 attributes in our schema, Ldap schema. So here, as you can see, we have added 24 register PCR0 to PCR 23. Then we have updated the free API interface, also the free API command line tools support the creation and the management of this new this new type. And we have added a new host group paradigm, which is a host Amsec attested host, which is here colored in green. We have added the Amsec suspicious host, which is a host that have attestation check failed for one time. And we have added a host group banned, which is a group that a quarantine group, which is which contain a host that fail five attestation 5 times. So to demonstrate this, we have done the flow to host enrollment using one-time password and using a TPM attestation. So the administrator authenticate to our interface, to our Amsec manager via his login and password. So the first step, he requests an access token from Keycloak as an authentication server. Then he will use this access token for all exchange between the Raspberry Pi and the Amsec manager. So he start RP enrollment. The first step is he will request a one-time password from the manager. The manager contact Free API to obtain the one-time password. This one-time password is used in our case to prevent to limited access to user that can enroll directly from Ldap. So to be clear, we cannot share the Ldap password to enroll host for everyone. So that's why we can pass from Keycloak to obtain access token if user have authorization to enroll hosts that they will obtain an one-time password, and this one-time password, it can be used for 13 minutes to enroll host in our infrastructure. So the Amsec manager will respond with the nonce and with the one-time password. Then the system installed in the our script installed in the Raspberry Pi will enroll host Raspberry Pi to the Free API machine using the API install client, and then he will start to generate a TPM code, which is our initial state of PCR from 0 to 20 to 23, and sign them with the nonce received in this step. Then we will pack the code and the endorsement key and attestation key inside a file. We call this a code TZZ. Then we will send this file for evaluation in the Amsec manager. So the Amsec manager will input this file, and he check all certificate and check if the code was well signed with the nonce generated in the step 4. If it good, if the validation is, if the check is valid, we added the host in the Free API, and we save the good PCR state. Then we will respond with success to the user management. So once the host is enrolled, we can use SSD, we can use NS to connect an SSH in our machine and our devices, etc., etc. So this is a video that I will demonstrate the flow described here. So in the top left side, I have the SSH terminal for my Raspberry Pi. In the top right side, I will start my my manager. In the bottom left, I have API interface, and here in the bottom left, I have the Amsec security interface. So the first stage, I start my my Amsec manager. So my Amsec manager have two parts. So the API part that is a secured API to accept, enroll, and validate the PCR. And I have an interface to visualize some information with visualization manner. So now I will use my login and password generated in the flow number 1, which is demo Amsec. So I can connect with demo Amsec to my MySec Amsec manager. So here we can sound the exchange between the API, between the interface and the API. Now I will connect to my free API interface, and I will go to the host's management. So here the user management, and I will go to the host manager. So at this stage, I have only two hosts enrolled already in my infrastructure, which is my Keycloak machine and my manager Amsec machine. Now I will add a new Raspberry Pi to our machine. So here in the Amsec host Amsec manager, I show you a sample functionality, which is I will show the available hosts in our infrastructure. In this case, we have not already available machine, so the list is empty. Then I will start enrollment of my machine. So we have a Python script which called Amsec worker. So I will enroll with forcement. So the first stage, a user need to log in to obtain an access token. So normally I will demonstrate with fake password, and normally I will be rejected. Okay. So to show you that the enrollment process need to be authenticated via our authentication system, which is Keycloak. So now I will repeat the Amsec enrollment process. So I log in with my demo Amsec user and with the good password. The first step, I contact the Amsec Management API to request an access token. I have obtained my access token. Then I will configure some parameter and I will request announce for host enrollment and the password, a temporary password for host enrollment. So here we can see the log to success enrollment authorization, and I obtain my temporary password for host enrollment. So the host enrollment step is I configure my Ldap configuration. I download the certificate, the API certificate. I configure the sudo file. I configure the SSD config file, and then I generate an SSH public key, an SSH machine key, and then I configure the Ldap file. So this process takes some time, and then I will restart the service SSH and restart the service SSD. After that, we will start a TPM attestation protocol. So here, the first stage, I request a nonce from my Amsec RPE. Then I will use this nonce to generate a code and to generate and sign a code for the 24 register. So the first stage, I contact the TPM hardware for generated a key. Then here I show you that the TPM is valid with the certification for manufacturers. And in this case, we have a secure global sign certification for STM devices. So then I generate I request the generate endorsement key, and then I generate a PCR list file which contain the hash of our firmware, which means the integrity check of our firmware. Sorry. Okay, then I will assign this PCR, this code with the nonce received, and then I will pack all file PCR endorsement key inside a code file, and then I send it to the manager. So the manager will receive this file, impact them, test if the code is well signed with the nonce generated in the step before. If all right, okay, so the node, the machine will be enrolled in our infrastructure. So as we can see here, for example, for our free API server, now we have the new machine added, the new host added, and we will show all details, like for example the SSH key generated, all the PCR that are initially computed by the TPM and validated by the attestation protocol. So this TPM value will be used in our attestation, our remote attestation protocol, and as every time we will check the same TPR, and we will compute the same PCR and check if the integrity is guaranteed or not. So now the host is enrolled. User load in our infrastructure can done SSH to this machine. So next, I will demonstrate the Pke Management, which is a certificate management. So this is a sample demonstration to show you how a user can, how administrator can request a generation, a certification for the client, and how can we use this certification to authenticate end user. And user means and devices. So it's the same flow. We request an access token from the key clock, and we use this access token in all exchange between Amsec manager and the free API. So the first step, I will request a client host certificate from our API. The Amsec manager API will verify the access token. If valid, they create a nonce for RP enrollment. So the nonce will be used to reply to avoid the reply attack. And then in the client part, we will generate some keys. For example, the public key, the private key in the client side, and then we will create a CSR file. A CSR file, which means a certificate signing request. This file will be sent to the free API manager, and then free API manager will sign this certification with his CA root. Then, if the CA root is signed, we will send back this certification to our client, and it can be used for exchange purpose. For example, if we have a secure services, it can be used for these secure services. So we have decided to generate a CSR file because we have the need to keep private key in the gateway host. So in the free API server, we only save the public certificate of the host, validate and sign it by the by CI user. So here the same demonstration. Now I will run the same script but for certificate generation. I will connect with my demo Amsec login. And then I will add some information about the host. And then I will generate a private key. And finally, I generate a CSR file. So the CSR, the demo, it's very quickly, but the CSR file was sent to the free API, to the Amsec manager, which impact the CSR file and generate a certificate for this user. So as we can see here, the subject is Amsec RP, which is my Amsec devices. And he generate a certificate and he give it the serial number 38. Then he sent back the signed certificate to user for usage for later usage. So we receive the cert, and the cert will be stored in secure part from the Amsec Raspberry Pi. So here, for example, if we come back to our identity manager, we will find the new host certificate added with the same serial number, etc. And if we have already enrolled host and added certificate, our devices can be used and it can be attested. So if we come back to the Amsec host attestation, we can find the last added host, and it will be tagged as Amsec attested because they have certificate and we have checked their TPM attestation, etc. So this is interface show us a simple interface to allow us to subscribe to one host, and we will check every time if the host is if the group host is changed or not. And this is it just for demo purpose, for a visualization purpose. So the next flow, which is Amsec devices authentication. So in the flow 3, I have generated a certificate for authentication client, and now I will demonstrate the usage of this certificate to secure and authenticate communication between gateways and other applications. So normally we use HTTPS for to validate and authenticate the server. In our case, we will use the SSL TLS client certificate to authenticate the client. So it can be a mutual authentication for more security reason. So the client use services. For example, here we decide to use Telegraph, which is a sample tools to monitor our Raspberry Pi. And we have configured the Telegraph services to use HTTPS with our application, which is here a database InfluxDB. And we will decide to use SSL TLS client authentication in order to authenticate the gateway. So then we will start the services. So the services is very simple. Each 10 seconds, he sent the data to be stored in the InfluxDB. So when the request received by our Nginx will check if the client certification is good, is not rejected, is not revoked, etc. And for this reason, we have integrated an OCCSP protocol and serial synchronization with our free API means that our Nginx has always a manner to check and to verify the certificate of our client here, of our Raspberry Pi gateway. So if the certificate is revoked, then all traffic between the gateway and our database will be blocked and all requests will be rejected. And this is a step I will demonstrate. This is a step in this flow. So here in the step in the top left side, I show you the telegraph configuration. Okay, so we will use Telegraph to send data to our InfluxDB. Our InfluxDB is secured with HTTPS with our proxy Nginx. And then we configure Telegraph to use the certificate generated in flow number 3. Then we will start the Telegraph services. So the Telegraph services will send every 10 seconds a telemetric or a monitoring devices, which is CPU disk, CPU usage, memory usage, and state usage, process usage, etc. And in order to visualize the information, we decide to use Grafana, which is a sample application, dashboard application for visualization purpose. And then we have configured Grafana to show us the dashboard of our Raspberry Pi metric. So as you can see here, I have obtained the uptime, the update time, the CPU usage, etc., etc. And then for demo purpose, I will run some. I will run some refresh. So I have a window for last minute and refresh for 5 seconds, and then we can see the data arrive in our database, Influx database, and this data will be stored every 10 seconds. Okay, so here we have received some data until 10 minutes, etc. So then we have the final flow for our demonstration, which is the remote auditing and attesting component. So as we explained, we use a TPM for remote attestation, and we will check every X time if the TPM, if Raspberry Pi is valid and the PCR are integer, etc. So we will rerun the same protocol for RP attestation. So we request announce, and then we create a code now for the PCR 5, 6, 7, 8, and 10, because inside this PCR we have saved the state of our hardware. And if the hardware have been attacked or the PCR changed, normally the code will be signed with announce, and in the verification part we will find a different value between PCRs. So we can say that the PCRs are not good, the validation is not good, and the attestation is fail. So if the attestation is fail, the free API system will put this hardware, this host in the quarantine. As explained at the beginning, that we have added 3 groups paradigm, a group paradigm. We have added attested host, which is a host that the remote attestation was success. We have added a group which is suspicious, which is the attestation was failed for one time. and a banned host, which is attestation fail for 5 times successive. So if we have a banned host for 5 times, the server will revoke client certificate for the host used, and then he will send a notification mail for the device owner to say, be careful, there is a the client cert was revoked, there is a breach in our mechanism, etc. So if the cert was revoked, these gateways cannot send data to our infrastructure. So the gateway will be rejected. The whole system will be operational and resilient. The only machine will be rejected from our infrastructure. So in the next slide, I will demonstrate this remote attestation. So here I open a new terminal and I will generate a sample attack which is based on nonce falsification. So if the nonce is modified, the code will be signed with non-good nonce, and the server will detect this incorrect nonce. So he will put the machine to the quarantine, and he will add the machine to the suspicious group. Sorry. So here I will start a first time attack. As you can see here, the protocol attestation was running. Then the server in this side, he cannot validate the nonce. So the verification certificate was failed. And then he will put the group in the suspicious group host. So I will repeat this attack 5 times successfully in order to show you when the host will be rejected from our machine. So this is the last attack. Also TPM attestation fails, and the host will be put in quarantine with Amsec banned group. As you can see here, for example, I show you here, for example, the log of our Nginx proxy. So before the attack, all request was success. Even the machine was in a suspicious group. In suspicious group, we have just notification, but not rejected machine. Then, if the attack success, the group will be put in the banned group, and all communication between the host and our system will be rejected. As you can see here, certificate revoked. So node cannot send data to our system. And as you can see here, Grafana, he stopped receiving data, and all communication between host and our machine was stopped. So I come back here to the free API interface, and I will show you that the certificate with number 38 for this host will be revoked, and all this automatically done. So then, as you can see, also Telegraph, in the console log of Telegraph, we will have an error to sending data, etc., etc. Then the Amsec was put in the Amsec banned group. And the final step was to notify user. So at the beginning, I created a demo Amsec user, and I updated the address email for my personal address email, because the Amsec domain, it's not already available. So for the purpose demonstration, I put it my personal email, and I will receive a notification from Amsec manager to notify me that there is an Amsec breach on host. So which means hello demo, there is a breach notification sent from Amsec security manager. Please notify that the remote attestation for node Amsec RPA was failure. It will be banned from our network, etc. In order to check the host and come back the host to our infrastructure, we need an administration, a system admin interaction. We need to change the identity in the identity manager free API. We need to change the group, and then we need to connect to the Raspberry Pi to check if there is a real attack or not. If there is a real attack, we can clean the system, recompute the PCR, we request a new certificate, and then we can reconnect our devices to our system. So this demo was defined to show you how we can do some remote attestation. If the remote attestation fail, we reject the host and we notify user and owner for the breach information. I give you back the panel, Mathieu. Mathieu. So if you want to know more.
Sorry, I don't know why I was mute. Thank you, Radhouene. I think we have some room for questions, if there are any.
Yes, Mathieu, we actually have one question that was posed through our chat, but for the other participants, please feel free to either ask your question in the chat box or raise your hand in the raise hand function, and we will give you the floor. So, but meanwhile, while there are no further questions, I have one here from one of our participants, which states that if the Amsec framework is still secure after presenting all the details to the public, like the details that have been explained in this webinar. So if there are still some security after presenting all the features of our Amsec framework.
Yes, actually, that's a good question. Of course, it's still secure because what we have presented is how we can integrate tools validated for security all together in order to connect a domain which usually in security doesn't work together. So the information that was released today, it doesn't compromise the system. The attestation showed by Radhouene and the enrollment protocol, and all of these are actually specified by the Trusted Computing Group, and they are based on cryptographic functions. So the release of information doesn't compromise this cryptographic function as long as you use them in an appropriate way. Is there another question?
Thank you, Mathieu. So there's a second question regarding what is encryption strength?
So the encryption strength depends of the, in our case, on the TPM capabilities, which are hardware capabilities. The TPM specification evolves. So when there are new encryption protocol and with longer keys, mostly because it's what we're looking for, the TPM can, the newer generation actually can handle longer and longer keys. So as of today, there is the SHA 256 hashing protocol, which is supported by hardware. There is AES encryption, and there is also elliptic curve-based encryption. Actually, if the hardware doesn't handle an encryption protocol, which is and that we seek for a new kind of or custom encryption protocol, we have alternate ways to do so by being secure, not maybe not certified in a common criteria way, but there is still capabilities to use, for example, trusted execution environments to support protocol which are not supported in a hardware way. So in this way, we will have a software encryption, but with some security, for example, using this kind of trusted execution environment. Okay.
I don't see any further questions, at least in our chat box. So this would be the final call for any questions that you may have. Nevertheless, we will send you, all of you who have registered and participated in this webinar, a follow-up email. This follow-up email will contain not only the video recording of this webinar, but also the PowerPoint presentation and some more interesting links about our Amsec framework. So please feel free to reach out if you want to be engaged or if you have a specific question regarding our solution. You can always reach out by answering our follow-up email or sending us an email to our hello@amsecproject.eu, which I will share with you here in the chat function. So here you can always send us an email. So a couple of messages from my side before finalizing this presentation. First, thank you so much, Mathieu and Radhouene, for the very interesting presentation on how to aggregate all the layers of the Amsec solution. As you are aware, the Amsec is a research and innovation collaboration project between the EU and Japan, and its main goal is to develop an innovative solution, which we call the Amsec solution or the Amsec framework. And the idea is to ensure a more secure and less vulnerable data transfer between all the stakeholders that are present in a city context. So between citizens, researchers, companies, developers, local municipalities, and the idea is to create a more secure framework when all of these stakeholders are using IoT devices and applications. So today was all about demonstrating how this specific solution can provide a more secure framework for all of us who are using IoT devices and applications. And in the scope of this research, we are also conducting an online survey to all EU and Japanese citizens and stakeholders, which can be considered as potential users of our solution. So we would like you all to also participate in this survey. The main goal is to collect your experience when using IoT devices, but also your knowledge or your awareness of EU or Japanese data protection regulations. And I will send you the link to this survey in our follow-up email, but I will also put it here in the chat so that you can take a look. This will not take you more than 1 minute to participate, so please help us better understand what is your experience with these devices and your awareness regarding the regulation. And last but not least, we will have another webinar which will be held on the 9th of March. This will be a more broader Amsec presentation, and it will be focused on the applicability of the Amsec solution in real life use cases. So we will present several use cases that showcase how this solution is improving the well-being of population in hyper-connected cities where we all use IoT devices and applications, and how the solution can ensure the security and safety of the data that is transferred. This, of course, like the survey, will come to you in the follow-up email. Nevertheless, I also send you here through the chat function the registration link. So today's webinar was a more specific and more focused presentation, a more technical presentation, let's say. The webinar on the 9th of March will be an overall, a much broader presentation of the Amsec and its real applicability in a smart city context. So I do hope that you can register and be there to pose all your questions to us, to the Amsec team. So from my side, thank you so much to all of you who have participated. And thank you so much to Mathieu and Radhouene for the interesting presentation, and see you all in our next webinar. Thank you so much, everyone, and have a very, very busy and interesting working day.
Thank you. Bye-bye.
Thank you. Goodbye, everyone.
Bye.
Thank you.